Hello, everybody. Welcome. My name is Danni. I work for Redis Labs. And today I'm going to talk about a module that I've been working on for the last year or so. The module is time series, obviously. And I will start and talk a little bit about my experience and my history with time series. So about a few years ago, I was working for a small security startup. And we were doing a security product that was installed on the customer location. And normally you are not allowed to connect to the customer location whenever you want. And the customers, when he has some issues, he calls you and then he gives you connection and you can go ahead and look what's going on. So pretty fast we noticed that it's really hard to connect and see what's going on in the product without having any previous data. So we used logs, but normally logs are getting rotated. And it was really hard to understand what was going on a week ago, 2 weeks ago, 3 months ago. So we started to use Graphite. So probably a lot of you use Graphite or know Graphite. And we were really into Graphite, and we started pushing a lot of metrics. And what we saw is that it gives us a lot of visibility of what's going on inside the product. Without even being connected to the product and seeing that in real time, we could have seen the history of what happened. So over time, we got really invested in that, and everything that we did, we had some metrics in Graphite. So that was the first time I truly found out that time series are a great thing and how much you can do with that and get a lot of information, insights, and even debugging stuff. So for QA, for debugging, for real-time analytics, it was very useful for us. So when I got to Redis Labs, one of my first tasks were to improve our monitoring stack and our internal and external monitoring stack. So in Redis Enterprise, when you install it, you have built-in statistics and metrics that we use to show our customers what's going on inside the product. And we also have our cloud offering. So over there, we have many, many machines that running on the cloud, and we also need to monitor that. So this is my take on time series. So I got to doing this module for time series from the IT perspective, from the monitoring perspective, and that's what we're going to talk about today. So before we're going to start and talk about Redis time series, let's start and talk what are time series. So time series is basically a list of samples where each sample is a timestamp and a value. So if you want to graph that, it's really easy to graph. So if you look at the graph that we have there, we have 7 samples. They are spread around by an hour. Each sample is an hour, and we have a value for that sample. So if you take multiple samples in an array, for example, then you have a time series. So you can easily graph that, can easily visualize that. So time series are coming from multiple sensors. So I'm coming from the IT industry, and we have a lot of IT metrics, which is CPU and memory and maybe temperature and so on and so on. But today with IoT, you have lots of data. Sometimes it comes from sensors out there. Sometimes it comes from machines. It can be everything today. Okay, so once I got and understand better time series, I found that there is a very unique characteristics of time series. One of the most important features, or the way you use time series, is by ranged query. So unlike other data types, you usually get the data by a range time. So you have a start timestamp and an end timestamp. You don't have some random access. It's mostly around the timestamps. It's really easy to compress time series data today. Facebook, a few years ago, released a document, a white paper called Gorilla, where they introduced an easy and simple solution to compress timestamps with double delta, and even floats by using the XOR. But there is also other techniques, other mathematical techniques, and there was a lot of progress in the last few years about how to compress this data. Indexing. So timestamp indexing is also an interesting way of indexing the data. So Salvatore in Streams are using a radix tree to do that. A radix tree is also a very quick way of finding out where the data is by timestamps. And one of the things that I took and used that assumption in my module was that most of the time your time series data is append only. So if you are ingesting real-time data, most of the time the timestamp for a specific time series will not occur again. So we're in RedisConf, and we are talking about time series. Redis doesn't have any specific time series implementation, so why we are talking about that? Well, actually people already been using Redis for time series. So if you Google Redis and time series today, you will find out there is many articles about storing time series in Redis. So most of those articles talking about sorted sets. We in Redis Labs already been using sorted sets for many years. We have our own Lua-based scripts to append the data to sorted sets, query the data, and do roll-ups or compaction. Everybody uses a different naming for that. But mostly, a lot of people already been using Redis for that. Why would somebody use Redis for that? As in any other use case, well, Redis is very fast. If you have a use case that you need your data really fast, you will probably think about putting it in Redis. So what kind of data you want really fast? So a lot of companies have dashboards today. Dashboards are really an easy way of seeing what's happening right now. And if you want to see what's happening right now, you need the data really fast. So if you want a quick dashboard, you will use Redis. Querying the data from a traditional database or even a time series database will take time. But unlike any other database in Redis, it comes from memory, so we can serve the data a lot faster. Another important thing that's happening today is that we have more and more and more data, and it's really hard for traditional databases to ingest that data as fast as the data grows. So if we go back to the Facebook example, they created the Gorilla document because they have so much IT data, so much metrics that they want to store and alert on them that they needed to create a whole new solution just for that. That solution today is open source. They call it Baron Guy. So they created the in-memory time series database that is sharded and it's clustered. So if you think about it, basically they created Redis just for time series, which is a little bit funny. Also, Redis is really easy to maintain, it's really easy to deploy, it's really easy to embed. So if you want to embed Redis for time series, the only thing you need is the Redis binary and maybe a binary of the module. So sorted sets. Sorted sets is the default way of saving time series data today. As I said before, if you Google Redis time series now, in the first page you will get 10 results. 8 of those 10 results is how to use sorted sets for time series. So everybody is doing time series using sorted sets. So how does it work? So sorted sets is actually a set where you have a score and you have a value. But the value is important to remember it's part of a set. So if you want to use only the sorted sets for time series, you need to do some kind of a way of making the value unique. So many people are doing JSON inside of the sorted sets, and they're taking some random data or even the timestamp and saving that in the sorted sets value. So the rank of the value is the timestamp, and the value is timestamp plus the value that you want to actually save in the time series. Another technique that we utilized in Redis Labs is using the rank as the timestamp, and the value will be some kind of a reference to another key, and that other key will be a hash table with the actual value. So I have a small example here. So the first example, we have a temperature, and then we have the timestamps, and we have a JSON. That it's the timestamp plus the value. And at the bottom, we have example with external keys. So if we use those examples, for example, the bottom one, you can use multiple values, and you still have uniqueness. But if you want to query the data, you still need to do a Z-range query on the sorted sets, and then you have all the keys, then you need to go again and fetch those keys from Redis. So you have multiple hops between you and Redis. Another option of doing that is using Lua scripts, but then you need to maintain, you need to test those Lua scripts, and basically you're tied to writing that in Lua. So this is how Redis Labs started to think about a better way of doing time series in Redis. So we came at this approach from our own experience and the stuff that bothers us when we are trying to use sorted sets of time series. So what is the module exactly does? The module adds another custom data type for Redis for time series. So in this custom data type, each key is a time series. So it's a list of samples where you have each sample is a timestamp as a value and a value, as we said before. And this is a native type for time series. So you don't need to use sorted sets. You don't need to do multiple queries to Redis to get all the data. And it's very optimized just for time series. One of the key features about using that module in Redis is that you can also utilize the features we already have in Redis, which is persistence, replication, failover, and all of the basic features of Redis that we all know and love. So basically, we're adding another level of functionality to Redis as time series. So what are the key differences between sorted sets and the time series module? So one of the important features that we added is the availability of ranged queries with aggregations. So you can do an aggregation of an average, a minimum, or sum, or a count, which you cannot do with sorted sets. If you want to do that, you need to fetch all the data from sorted sets and do it by yourself. Or you need to write a Lua script for that. We have automatic downsampling. We're going to talk about it a little bit later. And you have a retention time. You can pick whatever policy you want for your keys. If you want to save the latest 24 hours data, or you want to save, let's say, 1 month, you have the ability to do that automatically. You just ingest the data, and the module will do all the functionality for you. It is memory optimized. We only keep the timestamp and the value, so you don't need to duplicate the timestamp as you do in the time series. You don't need to create multiple keys. You can only use just one key, and it's supposedly only optimal for time series. And as we said before, we utilize less traffic between the client and the server. Even if you use the aggregated query, you can get much better traffic performance because you will get less data back from your Redis. Okay, so now we're going to go through the commands that the module allows you to use. So the first command is the tscreate command. This command creates a key with the time series. So you have two configuration options for the tscreate command. The first is the retention in seconds. So if you want to retain the data for X amount of seconds, it can be days, it can be months, it can be years. It's important to remember that the retention time is not depending on the current time. It's the difference between the newest sample and the oldest sample. So you're not attached to your current the Redis clock. It's also remember to know that it's important to know that the retention time is doing the deletion in a lazy way. So if some data is older than the retention time, the module will wait to have enough samples to delete, and only then it will delete a bunch of samples. That way we don't duplicate a lot of data and we don't move a lot of data in memory, which is less efficient. The other configuration option is the samples per chunk. The way we keep the data in memory is by chunking the samples. So each chunk has X amount of samples. The default is something sensible. You might try and play with that to find different performance according to your specifications. But the default is supposed to work quite well for you. So we have example here for how to create a temperature key, and the retention policy is 24 hours. Okay, so now we want to add some samples
to the key. So we have a time series database, we have a time series key, and we want to add samples. So in this example, we have 3 samples. Each sample has its own timestamp, of course. The difference between the timestamps can be this, it can be 1 second, it can be 10 seconds, and every new sample doesn't have to be the same difference from the previous samples. So you can report every 1 second and then move to reporting every 10 seconds. There is no heartbeat or nothing like that. So it's up to you what's the interval that you want to report to the time series data. It's important to remember also there is a small caveat. You cannot report any data that is older than your latest data. So if you reported, let's say, the 915 sample, you cannot report anything older than 915. The reason we're doing that is because the way of the memory module for the memory model for the time series, we prefer not to report all data, to not move the time series, the samples that you already reported, because if we do that, it will hurt your performance. Okay, so this is one of my favorite commands. So a lot of people use Redis today for counting. So let's say you are in mobile gaming, or you have a web app or e-commerce, and you want to count how many people viewed something, how many people are online, how many people have been playing your game. So a lot of people, what they do is they use the incr by and decr by command, or hincr by and hdecr by command. So those commands, what normally people do is that they truncate the date, or they bucket the date, and they have a key for each bucket. So they have a key for the year, the month, the day, the hour, and maybe the seconds or the minutes. And what they do, they will incr by those specific buckets for that specific counter. So if you use the ts incr by and decr by command, you actually can have the same functionality, but you can also have the history automatically. So if you call a ts incr by command, we will give you the automatic functionality of a time series, but you can also get your latest sample and know what's the current counter. So in those two examples, we can see we're counting the active machines. The first example will add 3 machines to the active machines counter, and then we're gonna decr by that counter by 1. So the current counter is actually 2, but if you do a range query on the active machine key, you're gonna see that it started as 3, and then it was decreased by 1, and the current status is 2. So you can do that as multiple times as you want, and the timestamp that will be used for that key will be the Redis clock. So if you trust your Redis clock, that's the best way to do that. It's actually a very good way to do that, because if you have multiple machines and every machine has their own clock, you need a way to synchronize the clocks so you won't have any contentions. So using the Redis clocks is actually also a good way of minimizing that contention. The other feature you can use with ts incr by and decr by is the reset bucket. So let's say you want a counter and not a gauge. So the active machine is more like a gauge. You want to gauge how much you have right now, but maybe you want to count something like active users. That active users can be online, but they also can go away. So we want to bucket them by time. In this example, we're bucketing it by 5 seconds. So every 5 seconds, the counter will reset and start from 0. So in this example, every time there is an active user, let's say our backend will probably have some kind of a heartbeat, that every 5 seconds will send a heartbeat that the user is active, and then the backend will call the ts incr by with a reset for 5 seconds. Okay, so now you have the data in Redis, and you want to query it. So how you do that? Use the ts range command. Ts range command allows you to get the data from a specific start timestamp to an end timestamp. And then you can also have aggregations. So let's say you have a really big key, and you have a key that holds samples for 1 year, and each sample is 1 second interval. That's a lot of data. And if you want to graph it, it probably will look a little bit condensed because there's too many samples, and also it might hurt the UI because the UI will get a lot of samples from the backend. So you'll probably want to do some kind of aggregations. A lot of people use mostly average, but it's important to know your data and know what you're graphing and use the correct aggregation method. So using the tsrange command, you can query the raw data, but get an aggregated data. The aggregated data will be much smaller, and it depends on your bucket size. So if you want, for example, at the bottom example, you have a temperature query. We have from X timestamp to Y timestamp, and then we want to average the timestamps to 5 minutes using average. So that's the aggregation here. You can have average, max, minimum, count, and sum averages. So all the aggregations around the time series are all the same. So everywhere where you can use aggregations, it's all the same aggregations. Currently, it's those 5. But in the future, we probably will add more. That's it for tsrange. OK, so downsampling. So many of you probably used some kind of a time series database before. And most of those time series databases already have something that's called downsamplings. Some people call it compaction. Some people call it compression. There is numerous names for that. I like the downsampling naming. So what is downsampling? So on the left side, you will see a graph. The graph is I think it's 10 minutes intervals of samples. That's our raw data, for example. And that data is what we get raw from the backend, some sensor, something. And we want to keep that data for 24 hours. But after 24 hours, we want to conserve on data size, and we want to downsample it. So downsampling allows us to keep the majority of the data, but still lose some information, some data. So on the right side, sorry, on your left side, on your left side, you will see the downsampled graph. So the downsampled graph, we went from a 10-minute interval to a 1-hour interval. We keep 10x less data, but we still have the majority of the information. So you can see that the graph was around 48, and then it went up above 194. So we still have that core data, but we keep a lot less data. So memory and RAM is expensive. So if you're on Redis, it is expensive. So you probably will want to keep less data. So downsampling is a very useful technique for that. It's important to remember what is your data and know your data very well, so you use the right technique to do that. So the way we do that with Redis-Time-Series is what we call downsampling rule. So every key can have multiple rules. Those rules are actually the way we downsample the data. So a rule is aggregation, so a type of aggregation that you will pick. It can be average, minimum, maximum, count, and sum, as I explained before, and a time bucket. So if you want to aggregate by 10 seconds, 1 minute, 2 minutes, 1 hour, it's up to you. You can pick whatever aggregation and time bucket that you want, and you can pick whatever destination key you want. In this example, we are doing an aggregation of temperature over 60 seconds with an average. You can pick whatever you want. And the destination key will have the aggregated data, the downsample data, and the raw data will still stay in your original key. So you will have both data, and it's up to you to query the right key if you want the raw data or you want the aggregated data. You can have also different types of retention policy for different keys. So the raw key can be for 24 hours, and the downsampled key can be for, let's say, 1 week, 1 month, 1 year. It's up to you. So you can keep for a long period of time the downsample data, and the raw data you can keep for a short period of time. The performance impact of the downsample rules are very little. It is some performance impact, but what we do is that when you call the tsadd command, we only aggregate it on the fly. So for example, for an average, we only count the sum and the count. and only when the time bucket of the aggregation is finished, only then we're going to flush it to your destination key. So this allows us to have a very fast ingestion rate, but still have multiple downsampling rules for each key. So as I explained, if you want to use the time series, you need to create a key. But most of you will probably want to just call the ts-add command and create the keys automatically. So the way to do it is by setting the global configuration when you create the module. When you load your module, you can have a policy, a default policy for downsampling rules and default policy for latencies. For retention time. So the retention policy and the aggregation policy will be automatically used when you call a ts-add command for a key that doesn't exist. So you can have whatever policy that you want for any key that you're gonna ingest to. So every policy will have the aggregation, time bucket, and retention time. So, and you can have as many policies that you want. You can have different policies. It doesn't have to be the same. They do not interact with each other. So each downsampling rule, which is what we're gonna create from your configuration, is totally independent, and they're not colliding with each other. Okay, so what is the recommended key topology when you use the time series? So what I suggest is for you to use the key name as your identification. So example, in here we have temperature sensors. That's our examples. And we have multiple of them. So you probably want to use some kind of identification inside your keys. So you're going to use a temp sensor, -43. So that's the identification of the sensor. And when you create a downsample rule, you will probably also want to add those information of the downsample rule to your destination keys. So temp sensor 43 will have two downsample rules. One is average and one is maximum. And they're both 60 seconds bucket. So you will have two destination keys, and you will encode the aggregation types and the time bucket into that key name. If you use the automatic global configuration, we do that automatically, and this is the same formatting that we're going to use. We're going to use the original key name underscore the aggregation type underscore time bucket. Okay, so a lot of people ask me about streams and how this relates to streams. So the time series, as we see it, is a subset of streams. So streams are a more generic time-based data structure. So you can host their logs, you can host events, you can utilize it for time series also. But when people talk about time series, they are looking for features that are unique for time series. If it's downsamplings, aggregations, retention, those are key features that every time series database out there uses, and those are features that people who use time series usually look for. So in the future, we're gonna probably use the data type of streams as an underlying memory module for the time series. We're gonna keep and utilize the assumptions of time series and have those specific time series features that are unique for that specific data structures to have better functionality for people who want to use time series. Moreover, when we're talking about streams are very generic data structure. So the compression that you can achieve there is a little bit different because if you're using events or logs, you can't really compress it. But when you talk about time series, you can compress it much better because you know that all your data is numeric. So when we're talking about numeric data, we can do source, we can do much better compression, we can do delta compressions, while when we're talking about logs and text, it's much harder to do those compressions. Okay, so finished a little bit early than I expected. So now it's Q&A time. Yeah.
So this seems really interesting to take it in the direction of making the stored time series, how it's sampled, observable, so that you can detect anomalies and perhaps have a subscriber mechanism to alert about this sort of thing. Is that something that this mod is in scope for this module's feature?
So the question is, whatever there will be any subscriber module like the streams and like pub-sub subscriber module.
You're submitting these samples.
Mm-hmm.
So some of these samples might indicate anomalies because they're so much different than previous samples. And in your downsampling, you're like picking maxes and mins based on some choice.
So
Some average. It's a notion of what is average.
yeah, so you can pick whatever aggregation type you want. So you can pick maximum, minimum, average, or you can pick all of them. So
Sure, so when something's extremely anomalous based on a historical trend.
you have a microphone.
So when something's extremely like an anomaly, is that detectable in an observable fashion? So like can I as a pub-sub channel subscribe to anomalous behavior of time series when you enter samples?
So the question is if we can do in real-time detection of.
And my question is that something you've thought about, or is it something that's potentially in the future scope of this or a similar module?
It's not something I thought about. As I said, my take on this is coming from the traditional IT, if you want to like graph stuff. But technically, that's doable with even something like a module that you can alert on key space. You can get key space notifications and check the data in real time inside Redis. But maybe we should talk after that, and I understand better your use case of doing some real-time analytics inside Redis. I think that's your take on the, okay. So nothing at the moment.
What if the sample rate is the same? In which case, your database overhead is too big because you really only need perhaps beginning and sample rate to describe your time series.
So the
second question is related to the anomalies. What happens if you have a hole in your time series? You know what I'm saying? I mean, zeros or null value.
Sorry, again, what's the question?
Well, sometimes you may not have samples, right?
Yeah.
Null values, so-called null value in time series. Do you have a way to handle that?
Okay, so the way I do, the question is what you do when you don't have samples.
Yes, the first question is, what if the sample rate is the same? Then your database is basically, yeah, you're storing the timestamp, which may be oversampling because you know it's equally sampled.
So the next step is adding compression. So if you do double delta compression on timestamp, if your timestamp intervals are the same, you only waste 1 bit per sample. So we don't do that yet, but we plan on doing that. So we don't really spend more space on the timestamps than you must do. So it's actually a very easy technique to do. Yes.
And what about the holes in the data, holes in the time series?
Okay, so the module doesn't expect any specific intervals. So whatever timestamp you give, that's what we will save. So it's like a sparse data. So we don't expect you to do the same intervals all the time. Like if you look at RRD or similar techniques, what they do, they have a round robin file, and they expect their samples to be in the same interval. So in this module, whatever timestamp you will give us, we will encode inside of the data structure.
Anyone else?
Does this data type support the CRDT sort of way of thinking? Because you said you could insert stuff back in time. So if you have a cluster where it's disconnected and keeps going, how do you merge this again?
So CRDTs do not work with this data structure. The reason we are not allowing historical data is because if you already got a timestamp and you want to if you report on the older timestamp, then we need to push it before the newest timestamp. So if your client was disconnected and didn't report anything, and then it gets connected again and it flushes the data, that will work fine.
Anyone?
Anybody else? Oh, there's another one here.
Sorry, I don't mean to just. This is not the same question as before.
No.
But I'm curious. So I know the motivation comes from a metrics gathering system, but I imagine there might be even some people in the audience here that are very interested in it from like a signal processing background that views the time series as a signal that maybe you might consider if there's I'm curious if there's been requests for like convolution in these operations on time series or if not.
Yeah. So like the question is whatever we do some more sophisticated mathematical approach for aggregating data while you query it, like having some mathematical functions and statistical functions on the data. So we don't do that yet. We might do that in the future, but we're focusing now at having some data structure that can hold and retain time series in an efficient way, and then those functions we probably will think about them later.
It is an open source module. So.
Yep.
Yes, I'm first hearing about it.
Anybody else? Okay, so yes, Louis?
So I was kind of interested in the I think you showed in the beginning where you have like a bucket and then you store everything but then as you're storing it, you can define how long you want to store it, and what does that mean that after that amount of time it gets deleted from the database, or that it just doesn't get pulled from the database? Or
Okay, so the question is how the retention period works.
Right.
So what we do is once you add more data, every time you add data, we check whatever we need to delete all the data according to the retention period. So if you didn't return any data, if you didn't add any more data, we will not delete any data. So the retention period is not according to the clock. So let's say you have a key with a 24 hours retention policy and you didn't report anything for the last month, we will not delete the data automatically. So the data will be deleted only if you insert new data, and that data is bigger, like the oldest timestamp and the newest timestamp are, the difference between them are bigger than the retention period. Only then we're gonna go and try to delete those old samples.
So it only deletes while you're adding records?
Yeah.
Okay.
Yeah, and that happens not every time you add a sample. We only delete data if there is enough samples to delete, and we drop them together, so we will not need to move any data in RAM.
Okay, thank you.
Does that mean it deletes using the TTL and then just a normal sweep that Redis does?
So if you use TTL on a key, it will just delete the whole key. So you can definitely have TTL plus the retention policy. So the TTL will make sure that if you didn't report anything in the last X seconds, it will delete the whole key. So that's something you can do. Anybody else? Yeah, another one there.
Hi, thanks. Do you have any performance metrics which you can share or will be sharing in the future?
I did some. I have something. It's unofficial, but I did get on my Mac. I got to around 120,000 samples per second, and I didn't try to do any improvements on the client. So you can probably get a lot more, and it's only one core. So I will definitely share some benchmarks in the future. Anybody else?
Thank you, Danni.
Thank you, guys, and.